Hello guys, so you're going to the 2025 AMC10A Problem 21. So a set of numbers is called sum free if whenever x and y are not necessarily distinct elements of the set, x plus y is not an element of the set. So what is the greatest possible number of elements in a sum free subset of 1 to 20? So we notice that for, let's say we have 2, 4, and 8, 2, 4, 6. Well, we can't have even numbers because we can always get from 2 to 4. Or let's say 6 and 12, we can always get from that. But conversely, if we have 1, 3, and 5, we can't double 1 to get to 3. So we immediately notice like this, that even numbers are bad. And so pretty much that's literally all we have to figure out for the problem. Since we can't have any even numbers, we have 1, 3, 5, all the way to 19. And obviously none of these numbers can add to each other because odd plus even is equal to odd, and odd plus odd will never add to any one of these. So 10 is a safe number, and that is our answer. Hello guys, so you know, 2025 AMC10A Problem 22. A circle of radius r is surrounded by 3 circles whose radii are 1, 2, and 3, all externally tangent to the inner circle and externally tangent to each other as shown in the diagram below. What is r? So we don't actually have a diagram for this problem, but basically it's like on the test it was something like this. With that. And obviously the diagram doesn't really matter. What we're going to use is called Descartes' circle theorem. Basically, this theorem states that like any 4 circles that are tangent must satisfy this equation. So basically, they state curvatures, which are just the reciprocal of the radius. So basically, we have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over r squared must be equal to 2 times 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over r squared. So now let's expand this. So we have 11 over 6 plus 1 over r squared. And this is equal to 98 over 36 plus 2 over r squared. And so now let's expand this. We have 1 over r squared plus 11 over 3r plus 121 over 36. This is equal to 98 over 36 plus 2 over r squared. So now we have 1 over r squared is equal to, what's 121 minus 98? That should be 23. Yeah, 23 over 36 plus 11 over 3r. Now let's multiply by 36 on both sides. We have 36 over r squared is equal to 23 plus 132 over r. Let me add a new page real quick. Now let's multiply by r squared on both sides. We have 23r squared plus 132r minus 36 is equal to 0. Now Pythagorean theorem time. Wait, what am I saying? Quadratic formula. R is equal to negative 132 plus 132 squared minus 4 times 23 plus times 36 all over 46. And also we have plus minus here. So now basically let's first factor out 4, and that turns us into negative 66 plus minus 66 squared plus 23 times 36 all over 23. Now let's factor out 6. This is negative 66 plus minus 6 root 121 plus 23 all over 23. This is just 12. 121 plus 23 is 144, which is 12 squared. This is negative 66 plus minus 72 all over 23. And so obviously this can't be negative, so this is 6 over 23. Hello guys, today I'm going to go with 2025 AMC10A Problem 23. So triangle ABC has side lengths AB is equal to 80, BC is equal to 45, and AC is equal to 75. And so the bisector of angle B and the altitude of side AB intersect at point P. So what is P? What is BP? Okay, so now let's let this angle be Q. Okay, point BQ. So let's first find the area of ABC. So the area by Heron's theorem, Heron's formula, we know that semi-perimeter is 100 by adding them all up and dividing by 2. And we have to take the square root of this times 20 times 25 times 55. So let's take out a 10. Now we can take out another 5. And we take out another 5. And we can take out another 2. Just for result of 500 root 11. So this is our area. So this means that CQ is equal to AB. CQ is equal to 2 times area over AB. So that means it's equal to 1000 root 11 over 80, or 25 root 11 over 2. So now we can use the angle bisector theorem, but before we use that, let's do Pythagorean theorem to find BQ. So Pythagorean theorem on BQC, we have 45 squared, which is 2025, minus 625 times 11 over 4. 625 times 11 is 625, 625, 6875 over 4. So now we have 8100 minus 6875, 41225. So BQ is equal to 35 over 4 over 2. So now we can do angle bisector theorem. Basically, angle bisector theorem tells us that QP to PC is equal to 7 to 18, because this is 7, 18 in the ratio. So we know that QP is equal to 7 over 7 root 11 over 2. Alright, so now let's do Pythagorean theorem on BQP, and now we find BP. So we get 1225 over 4 plus 49 times 11 over 2. This is 1225. Oh, sorry, not over 2, over 4. 49 times 11 is 539. So we get 1764. And that divided by 4 is equal to 441, and we all know that square root 441 is equal to 21. So BP equals 21 is our answer. Hello guys, so 2025 AMC10A Problem 24. So call a positive integer fair if no digits used more than once, it has no zeros, and no digit is adjacent to two greater digits. For example, 196, 23, and 12,463 are fair, but 1,546, 320, and 3,400, 321 are not fair. How many fair positive integers are there? Let's say we have now let's do casework on like the greatest number, right? So for example, let's say the greatest number is n. Then we must have on both sides of the equation both sides of the number we must have a strictly increasing and strictly decreasing. And so basically for every number we have three choices. We can either put it in the increasing pool or the decreasing pool, or outside the number, not included at all. And so this is just 3 to the x, where x is the number of digits included. And this is fine because there's only one ordering of, let's say, 1, 3, 4, 5, and 7 to put them in increasing order or decreasing order, so you don't have to worry about that. So a closed form is just 3 to the x. So now let's do casework on what the greatest digit of n is. So let's say n is equal to 1. So this means that this is 3 to the 0, as there aren't any other digits we can put in. If n is equal to 2, then we have 2, and then 1 can either be in front of 2, behind 2, or not included in the number at all. So that's 3 to the first. That's 3. We have 1 and 2. 1 can be included. 1 has 3 choices and 2 has 3 choices, so 3 squared. And so we can continue this all the way down until 9 is the greatest digit, and then we have 3 to the 8. And so basically, in total, the sum of this by sum of a geometric series is 3 to the 9 minus 1 over 3 minus 1. This is equal to 3 to the 9 minus 1 over 2. So now the question is, what is 3 to the 9? And I'm sure in the real contest you could figure this out, but it is 19,683. So we want 19,683 minus 1 over 2, or 19,682 all over 2. And so just by intuition alone, it's C. Hello guys, yeah, we're going over the 2025 AMC10A Problem 25. A point P is chosen at random inside square ABCD. The probability that AP is neither the shortest nor the longest side of triangle APB can be written as A plus B pi minus C root D over E, where A, B, C, D, and E are positive integers. GCD of A, B, C, E is 1, and D is not divisible by the square of a prime. What is A plus B plus C plus D plus E? Okay, so we have a square, right? So basically, let's set the side length to 2, and you'll see why later. But basically, we have two cases. And let's let AP equal to A and BP equal to B, just to save ourselves some time. So we have 2 is less than A less than B, or B is less than A less than 2. So let's first look at 2 is less than A is less than B. So for A to be less than B, then the locus of points has to be on this side of the rectangle, because then PB is always longer than PA. On top of this, since A is greater than 2, A is outside the locus of this circle, where the circle is the amount of points where A is less than 2. So this is the shaded area for case 1. And now for case 2, A is greater than B, so it has to be on this side of the thing, and A is less than 2, so A has to be this sector right here. And so now we have figured out what areas we are looking to solve for. So now let's do it. So now we set it to 2 because now this is 2 and 1, and since we know that this is an equilateral triangle right here, this is also 2, this is 60 degrees, and this is 30 degrees. So let's first find the area of this thing right here. So that will be 2 minus 30 degree sector of a circle with 4 pi, which is just pi over 3, and minus root 3 over 2. And now this bigger area over here, that will just be, well, first of all, the area of this red thing is needed, and this red thing plus this green thing equals 4 minus pi. So the red thing is just equal to 4 minus pi minus this. So this is 4 minus pi minus 2 plus pi over 3 plus root 3 over 2. And then we want 2 minus this, so we want 2 minus 4 plus pi plus 2 minus pi over 3 minus root 3 over 2. So what we get from this is we get negative 2 pi over 3 minus root 3 over 2. And we want to add this to 2 minus pi over 3 minus root 3 over 2 for the total area. This is just 2 minus pi minus, wait a second. Sorry, this is positive 2 pi over 3. So this is minus pi over 3 minus root 3. So this is just 6 minus 3 root 3 minus pi over 3. Since the total area is 4, we have to take it over 4. So 6 minus 3 root 3 minus pi over 12. It's our final probability. Adding up all the coefficients, we have 6 plus 3 plus 3 plus 1 plus 12. This will be 25, and that is our answer. Thank you guys for watching. Enjoy this video. Make sure to like, subscribe, and peace.